Since we're changing things up a little bit when we have an object move in a circle, we're going to move away from describing things in terms of the x, y, and z direction, and we're going to kind of come up with a new set of axes. Okay, when I say axes, think of the x-axis, the x-axis, the y-axis, and the z-axis. We're going to replace those with these new directions, the r direction, or the r-axis, the t direction, or the t-axis, and the z direction. So here I've kind of shown you it's hard because just like x, y, and z are in three dimensions, r, t, and z are also kind of three-dimensional, and it's hard to show three different dimensions in a two-dimensional screen. So I'm doing my best here. This is supposed to be a circle. Okay, it looks like an oval because I'm trying to view it kind of three-dimensionally. So this is like a circle that's kind of coming a little bit out of the page, a little bit. The r direction is always going to point from the object towards the center of the circle. So this is our new axis. It's called the r-axis. It stands for the radial axis. It points from the object, wherever it is, towards the center of the circle. That's going to always be our r direction. The next axis is the t-axis, which stands for tangential axis. It always starts at the object and points tangent to the circle in the counterclockwise direction. So when the object is right here, that's the tangential direction. And then we have the z-axis. The z-axis is perpendicular to the circle. So the z-axis will be coming straight up. And here I'm trying to show as best as I can that the z-axis and the r-axis are perpendicular to each other. And the r-axis and the t-axis are perpendicular to each other. All three of these axes are perpendicular to each other. Also, the direction of these axes change when the position of the object is different. So when the object is right here, this is the r direction, this is the t direction, and this is the z direction. But later when the object is over here, the r direction, again, it points from the object towards the center of the circle. The t direction points from the object tangent to the circle in the counterclockwise direction. And the z direction points straight up, perpendicular to the plane of the circle that's being made. Okay, so here I have a ladybug. The ladybug is pointed in one direction, and I just want to know what direction is the ladybug pointing. Well, this is the circle that she's going to make, is the blue line. Well, that ladybug is pointing in the positive t direction. She's pointing tangent to the circle in that counterclockwise direction, so she's pointing in the positive t direction. How about over here? This ladybug is also pointed in the positive t direction because she's tangent to the circle in the counterclockwise direction. How about this ladybug? This ladybug is in that tangent direction, but she's looking clockwise, so that's going to be the negative t direction. Okay. What about this ladybug? What would you think? Well, this ladybug is pointed towards the center of the circle, and that's the positive r direction. How about this ladybug over here? Well, this ladybug is pointed away from the center of the circle. The positive r direction at this point would point inwards like that. She's pointing away, so she's pointing the negative r direction. To do the z direction would be coming out of the screen, so I can't really show that. But the z direction from this orientation would just be coming directly out of the screen. So now that we kind of have played around with a little bit with these axes, we can start describing velocity in these three directions. V sub r would be the component of the object's velocity that is directed towards the center of the circle. So if a ladybug just started walking towards the center of the circle, that ladybug would have a positive V sub r. The tangential velocity is the same tangential velocity we've been describing for the last week. This is the tangential velocity we've seen before. Now we're just saying exactly what it is. It's a velocity that's in the direction of our tangential axis. It's in the direction that's tangent to the circle. It's positive when we're moving counterclockwise. It's negative when we're moving clockwise. A v sub z would be a velocity in the z direction. That would be like if the ladybug, flew off straight up from the circle. So let's practice with these. Okay, so here's going to be an object. It's going to be moving. I want you to consider the value and the sign of the v sub r, the radial velocity, v sub t, the tangential velocity, and v sub z, the velocity in the z direction. So which of those are 0? Which of those are positive or negative? What would you guess? So in this case, for this example, The object is not moving in that radial direction, so that's 0. The object is not moving out of the plane of the page or into the plane of the page, so v sub z is 0. But the object is moving clockwise, so my tangential velocity is negative. Let's consider another one. Let's go like this. Sorry, the movement's a little jerky. That's the best I can do in this video. Okay, so I want you to consider again v sub r, v sub t, and v sub z, and whether those values are positive, negative, or 0. So in this case, v sub r is positive. This object does have a component of its velocity that's moving towards the center of the circle. It's also moving counterclockwise, so there's a component of its velocity, v sub t, is positive, but it's still staying in the plane of the screen, so v sub z is going to be equal to 0. Okay, we can also describe our accelerations in these three directions, the r, the t, and the z direction. Our acceleration in the r direction, we're going to call that radial acceleration. In the slides previous to this, I called it centripetal acceleration. I'm just changing the label. This is still the same thing as our centripetal acceleration. It's still the acceleration that always is pointing towards the center of the circle. We can also accelerate in the tangential direction, and that's the same tangential direction we learned about last week. That's the acceleration that's in that tangential direction. This acceleration here measures how fast this velocity here is changing. And then if our object were leaving the plane of the circle, we could describe an acceleration in the z direction. For our purposes in this class, we really are only going to focus on like a v sub t, a sub r, and sometimes a sub t. I'm just showing you these different accelerations and velocities for completeness. So let's look at this example, and we're going to try to identify what's happening in the r, t, and z directions in terms of my velocity, and the r, t, and z directions in terms of my acceleration. Now the animation here is not perfect. I intended this to be an example where this is moving at a constant speed. So let's consider this is at a constant speed, figure out whether my velocity in the r, t, and z directions are positive, negative, or 0. Well, I'm moving in the tangential direction, but I'm moving clockwise, which means my tangential velocity is negative, and my other two velocities are 0. And now we can start to think, well, what does that mean about my accelerations in these three directions, knowing that I'm moving at a constant speed? Well, since I'm moving at a constant speed, my tangential acceleration is definitely 0 because my tangential velocity is not changing because I'm at this constant speed. However, anytime you move in a circle, you have a radial acceleration. We previously called that a centripetal acceleration. We are always accelerating towards the center of the circle whenever we move in a circle, so that's going to be positive. We're not leaving the plane of the page, so this value is 0. Let's do another one. Again, I intended for this one to be moving at a constant speed despite the animation that's a little weird. So in this case, my tangential velocity is positive and my other two types of velocity are 0. And now again, let's consider what's happening with our accelerations here. Well, since I'm moving at a constant speed, my tangential acceleration is 0. This value here is not changing because I'm moving at a constant speed. So there's 0 tangential acceleration, but I am moving in a circle. And anytime you move in a circle, your acceleration in that radial direction is positive. You do have a centripetal acceleration anytime something is moving in a circle. Let's do one more. Now here we start from rest and we go faster and faster and faster and faster and faster. Okay, so we start from rest and we're going faster and faster and faster. That's what I'm intending with this animation, even though the timing's not perfect. But I intended this to be something that's speeding up as it's going. So it starts out slow and it goes faster and faster and faster. For my velocities, I only have a tangential velocity and it's negative because I'm going clockwise. And now when we consider what's happening with our accelerations, for this object that's speeding up, it's going faster as it moves. My tangential acceleration is not 0 because my tangential velocity in this case is changing. I start off slow and then I go faster and faster and faster. I'm speeding up. Whenever you speed up, you have an acceleration in the same direction as your velocity. So in this case, my tangential velocity is negative, and I'm speeding up, so my tangential acceleration is also going to be negative. Now, completely separate from that, I'm moving in a circle, and anytime you move in a circle, you do have a radial acceleration. This is what we call centripetal acceleration. That's positive anytime you're moving in a circle.